So once we've got a waste dump that fits our specific footprint, we can now come back and do some height optimization to work out what volume, or what elevation our crest needs to be to store a certain volume. So here in my dynamic model, I've come through and I've fit my waste dump to fit the outline that I want. I can look here at my dump volume, and it's 42.9 million cubic meters. So if I wanted a dump that was actually 60 million cubic meters, I need to go up in elevation. So I could come through and fiddle with here my crest elevation, but as I do this with this particular dynamic model, because it's just raising the crest up as it is, we'll see that the footprint of the dump expands. So this doesn't quite do what we want. So instead, what we can do is we can use another tool in the dumps menu called build a dump by volume. And this lets us take a dump design like this and then project the toe of the dump up until we store our target volume. Now the toe of the dump is the daylighted toe of the dump is a line where the dump shell intersects topography. It's a very complicated line. It's lots of points, changes in elevation, and it's a pain to try and project that up to a target elevation. We won't end up with the same kind of shell that we've got here. But what we can do is we can take the toe of the dump shell here, which is a nice geometrically simple line, and if we project it back up using the same slopes, bench widths, and heights, we should still fit the same footprint on the ground. And we can use that toe to then go back up to whatever elevation we need to get our target volume of 60 million cubic meters. So to get this line, we can go to our dynamic model here, and one of the outputs is toe. And if we just click on that button there, we'll see that it adds this toe line to our 3D window. So I can then come through, I'm going to hide all these other layers, and I can run the command dumps build a dump by volume. So I give it a guess for the elevation. So I'll say I know that it's going to be at least 150, but ultimately I want a 60 million cubic meter volume. My slopes, I'll use the same ones that I have in my dynamic model here, so 2:1, bench height of 10, bench width of 10. I don't want to merge it into my grid, and this will get it to within plus or minus 1% of our target volume. So I can then come through, hit OK, choose my base grid, choose my toe, and it will build the first dump shell to 150 and then do some height optimization to work out what it needs to be to get our 60 million cubic meters. So here we can see that the crest elevation actually had to be 181 meters to get 60 million cubic meters. And so this is how we can come through and work out, once we've fit a footprint, we can work out what elevation the dump needs to be. And if we just come back and verify that it's still fitting that footprint pretty well, I'll turn on the dump footprint layer. I'm just going to change the line width here so we can see it a little more clearly. And we can see that we're still pretty much in the same footprint. So this has worked out well for us.